Hi, so I'm quickly doing a question on vectors, just a quickly ordinary level question. Um, this question says, in the following figure, A, B, C, D, um, they say it's a trapezium. Now you should know that trapezium has got parallel sides equal, and AD is parallel to BC, as you can see by the means of those arrows. DE is equal to EC, and they have these two double primes here to indicate that those two sides are equal. And AF equals to FE, again you have a single prime or a dash to indicate that AF is equal to FE. And then BA is represented by T, and AD is represented by S, and BC is represented by 2S. So when the question says find in terms of, then you must give your answer in terms of those letters. Okay, here it says find in terms of T and S. Since it says and not and or, it means both or all of your answers here below must contain T as well as S. So another way that you can perhaps view this question, you can view this question as traveling or a route that you are taking. To go from D to C, you don't have anything in terms of S and T on this side. So you have to go, think of it as going in the following direction. So you're going from D and you go in this direction, you're going in this direction, and you're going in this direction until you reach your destination point. So D to C, I would say, is equal to DA plus AB plus BC. Now, here's the thing about DA. You are going against, right, S. So I'm going to put a minus S, and it's a vector. So you put a squiggly line underneath it. And then you're going against, because you're going AP against T, so it's just minus T, and then you're going along 2S, so then you add 2S. Now, just think of this as vector geometry or as like terms where this and this gives you nothing but S, and then obviously minus T. Okay, right, so the next one they want us to find is DE. Now, here's the thing about DE. We have DC from our previous answer. And we know that DE is half because these two sides are equal. So what we will simply say is that DE is half of DC. So therefore, DE equals to a half of DC. But we have our DC from the previous answer. So the only thing that you need to do is just say a half outside, and inside you have S minus T. All right, you can distribute over, but you can also just leave your answer like that. Then they want us to find A to E. So again, if you look at where A to E is, and I'm just going to take away this blue that I have here. So when you go from A to E, is you're going along AD and also along DE. We already have DE from our previous answer, so it's AD plus DE. All right, so that would be AD plus DE. Okay, refer to your diagram always so you don't get confused. And we know that AD is represented by S, and we know that DE from our previous answer at part B would be plus a half of S minus T. So it's just a matter of carrying over because you would probably see like terms there. Okay, no problem. So you have nothing but S plus a half of S minus a half of T. Now this is 1 plus a half, that's 3.5. Okay, so it's going to be the same as 3 over 2. So that is like 3 over 2 of S minus a half of T. All right, so Another way that you can also write this, of course, if you want to, you can take out the half, so to speak, and you have 3s minus t as a common factor. So any one of these methods will give you the same result. Now, the last part, they want us to find EF. So in order for us to find EF, you have to take into consideration, I'm going to remove again what I have on top here. So just think of it as a distance or as a route you're taking. So now we are going from E to F. So that is FE or EF. Let's just make sure they say EF or FC, correct? FC. So the distance that we now have to take is F to C. Again, we know that you can find this simply by saying, okay, wait a minute. It's the same as going from FE, because I have FE, which is something I have from my previous answer, or I can just quickly write something that FE is equal to, so you can just take note. If you go back to the diagram, you see that FE is equal to AF, okay? And then you go along EC. EC we have from our previous answer. Another way that you can also look at this, we know what AE is, all right? So AE, or if I come here and I say FE will equal to a half of AE. I hope you can see that, all right? Because AE is twice as long, so FE will be half of that. So we know what AE is from our previous answer, and AE we got from our C. So we now definitely can say, okay, FE will be half of AE, so FE is equal to a half of AE, which we know what is our answer with regard to AE from our previous answer there. So maybe if I just calculate FE, if I have to do that, because this is going to help us immensely. So it's a half. And let me just go back to my previous answer. And that's why I prefer to write it also in the other way or in this way. So I'll just say 3 half of S minus a half of T. And then I'm just going to simplify this a little bit to get my FE. So if you distribute over, you multiply, that give you 3 over 4 of S. Remember, numerator times numerator and denominator times denominator. And this is going to be nothing but a half times a half, which is negative 1/4 of T. Right, so what we have here is our FE. So this is FE over here. All right, so I'll go back to my diagram so you can see what is it that I've indicated, the route that we have to take in order for us to go from F all the way up to C. So it's FE, which we calculated, plus EC. Here's the thing about EC. EC, again, if you look at EC alone, let me just change this. We also see that EC is also equal to DE. Can you see that? And we know DE from our answer at part B. So we are just going to say whatever answer part B is, at part B, which is our value for EC, which is also equal to DE. So I'm going to say EC, which is also equal to DE, which is equal to our answer in part B. So I'm scrolling back and forth. It's a half S minus T. So that is a half and S minus T. Right. So you can also distribute this over. So that's going to give me a half of S minus a half of t. All right, so now I know that to go from F to C from my diagram that I have, and I'm just going to write it under here so that you can see. I am going to say to go from F to C, I will simply say it's going to be FE plus DE. So it's going to be FE plus DE. So let me just highlight again what I'm going to now add. So I'm going to add these two that is highlighted. Okay, so that means you're going to say 3/4 of S minus 1/4 of T. You're going to add a half of S minus a half of T. So we're going to add basically these two together. Okay, you can basically remove the brackets because there's no need for the brackets, not like we're subtracting. Okay, just make sure you get that. Okay, so from here is just a simple algebra that you have to do, sort of collect like terms if you want to. You have got 3/4 of S plus 1/2 of S, and you have negative a quarter of T minus a half of T. All right, so once you do this, okay, so the LCM here obviously will be 4, so this on top will be 5/4S minus the LCM is also 4. Okay, so it will be um, if you let me just maybe if because sometimes students they don't really see what is it that we do. Okay, the LCM here times 2 times 2. All right, so it will be negative 3 over, okay, so that will be negative 3 over 4t. Okay, just hope that you are working it out. Again, just grab a calculator if you are struggling with these fractions, so to speak. And so the final answer here would be 5 over 4s minus 3 over 4t. Again, you can also remove the common factor. Somebody can also say, so this is the final answer, which is also going to work 100%. Or you can also say, okay, let me take a quarter out, 1 over 4, and inside I have got 5s minus 3t. Okay, just remember that's a 5. Okay, any one of these will do. Okay, so it's quite a few workings that you need to show, and then you take it from there. Please work from the diagram, and if you get such a question in the examination, remember that you need to use a pencil and in order to work on the diagram in order for you to find the correct answer. Okay.